now that we are familiar with the new data set that we will be working with, let's actually get to it and implement the early stopping, or the saving of the best model.
So in this notebook, we are now covering the model checkpointing aspect, where we are training a model using the Lightning model checkpoints and save the best model during training so that we can use that later on. Again, we are going to start with Watermark just to make sure that we have the right package versions and our right Conda environment. So that looks good to me. And the next part would be, of course, importing all the essentials that we need here from the Lightning module to Torch, and then also the CSV logger we are going to use for tracking the performance of our model that we can then visualize later. Yeah, and we have again the custom data module and the Lightning model that are contained in our shared utilities file here. So we have the custom data module here. Okay, so this is what we discussed in the previous video. And in this video, we are going to now train our model. So we are importing or defining a PyTorch multilayer perceptron. That's the same multilayer perceptron we used in previous units, so no need to discuss this in detail. Then we are going to initialize a new model. And we know from the previous video that we have 100 features and 2 classes here. So let's define our PyTorch model here. Oops. But of course, I forgot to execute this code cell because we need this import here, as you have seen. So let's try this again. So this works now. And now comes the new part. So everything up to here was old stuff that we'd covered already in previous units. Now comes the new part, the model checkpointing. So first we're going to import the model checkpoint callback here from PyTorch callbacks, which is a submodule of Lightning. So that's a submodule containing PyTorch utilities. So what we have here is the model checkpoint, and we can define how many checkpoints we want to save. Here for simplicity, we only change 1 checkpoint, and we are going to monitor the validation accuracy. So for that, we have to make sure that our Lightning model tracks the validation accuracy. So in this case, we are tracking it here. However, if you don't track the validation accuracy, you could also technically just use the validation loss here. You would just have to change that here to loss. However, if you do that, if you use the loss, then you would also have to change the mode from max to min, because usually a lower loss is better. However, a higher accuracy is better. So the mode here defines essentially what we are interested in the highest or in the lowest value. Since we are tracking the accuracy here, we are interested in the highest value. So this is why we are keeping it at max here. And in addition to that, we are saving also the last model here so that we can compare it to the best model later on. Okay, so and this is really all we need, except for one little additional modification. When we define the trainer, we now have to plug in the callbacks here into the callbacks parameter here. So in the trainer, when we set up the trainer, we specify what callbacks we want. And since this is a list, we can have actually more than 1 callback here. So we are not limited to just using a model checkpoint callback. We could also use additional callbacks. So in this case, since we are focusing on model checkpointing, we are only defining the model checkpointing callback. And the options here are essentially similar to what we already covered in Unit 5. So there's nothing really new here. It's essentially the same trainer setup. And then, we are going to fit the model. Again, I have the habit of forgetting to execute previous notebook cells here. We do this again. So now the model is training here. And it should not take too long. Let's just see. I think it's 10 epochs. That should just be a few more seconds. All right, so now that the training has finished, let's visualize our log files. And for that, I'm going to use the plot CSV logger function that we already introduced in Unit 5. So what's new here is that I just put that into the shared utilities file, so it's not cluttering up our notebook. So it's right here, plot CSV logger. It's essentially the same function from Unit 5. All right, let's run this and take a look at the training logs. So as we can see, the training loss goes down as expected. The validation loss also goes down, except there's a little peak here, but otherwise it looks good to me. If we now look at the training accuracy and validation accuracy, we can see something interesting. We can see that the training accuracy goes up, and then at some point the validation accuracy goes up, but it drops. This might be just due to noise, but I thought it's just enough to illustrate here the model checkpointing. So what happens here is that the validation accuracy peaks at around epoch 9. So we are starting here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is essentially epoch 9. And we can see it's peaking here. So that's the best validation accuracy. And we might guess that this corresponds also to the best test accuracy or the best generalization performance of the model. So the model checkpointing should have saved this particular checkpoint here. So now we have saved the last model and this best checkpoint, and then we can actually use that in our test evaluation. Let us now use the best model after we check the log files. So we make a new section here, best checkpoint. And for that, we're going to use the trainer.test method. So before, when we used the trainer.test method, we just used it as follows, where we have the Lightning module here and then the data module. Now what we are going to do is we are specifying this checkpoint path. And here we have two options. We can say last or best. So let's actually take a look at the best checkpoint first. So this best checkpoint should correspond to this model here at epoch 9. So let's see how that looks like. So for that model, we get a 86.2% accuracy, test accuracy. And for comparison, we might want to compare that also with the last model. So let's put in last here. So for this comparison, this will load the last model after epoch 10, essentially. So when we compare those two, we can see that indeed the previous model, the model from epoch 9, performs better than the last model here. So in this case, checkpointing was indeed useful. Now, if you want to use this model in production later or something, if you are interested in finding out what path this corresponds to, we can also look at the path here of the best model. For example, I can say print path for this checkpoint callback best model path. So in this case, we can see what is the exact file. So we can also then essentially use that directly when we are loading the model. So for comparison, the last model would be this one. And then if we want to load this, let's say we want to use that later on, we can save our checkpoint on our computer somewhere else. And then we can use the load from checkpoint method here on the Lightning model and load our checkpoint. So this is a convenient way if you later on, for example, or in a separate code file or notebook, want to use this model. So let's just make sure that this works. So yeah, this works. It gives us the same accuracy as before. So this is just here a shortcut where everything is, let's say, saved in the current session of the trainer. However, if you want to, you can also save this path here, maybe in a node file, and then refer to the spec later by loading from this checkpoint using the path here. And yeah, in a nutshell, this is how we use the model checkpoint. I hope you found this useful.
So in this video, we learned about early stopping by saving the best model during training.